kind of where you're coming from, what your experience has been, and kind of what your company's doing now, if you'd like.
Sure, yeah, great.
Just
awesome.
take it away.
Yeah, so first of all, it sounds like, it feels like it's already this way, but let's just keep it casual. There's only a few of us, and if we grow, that's great. I'm Ken Syke. I've been out speaking at different conferences for a long time, so that's probably how I got hooked into this group in general. Perhaps, I don't know. I also was employee 22 of Mesosphere, which became Day 2 IQ. I recently had someone tell me I was one of the founding fathers of the cloud, which I found to be hilarious and awesome all at the same time. I don't think any of that's true, but I got started with that in 2013. I was heading up research and development, and they said, "Where's the cloud going to be in 2 to 5 years?" And humans are predictably terrible at predicting anything, first of all, but worse when it comes to technology. We concluded within just a few months that we thought Docker, which was version 0.3 at the time, Apache Mesos, and CoreOS were going to be the big things. CoreOS was always the wild card, just because operating systems in an enterprise, it's hard to, it takes years to vet and secure and all the things necessary to get an operating system to be sanctioned in an enterprise environment. So that was always the wild card. It's kind of fun looking back, right? Because you can look, it's past 5 years now. And was it Mesos? It was. But if you know me at all, I don't know if I'm tied to a brand, a label at all. The idea is really around containerization, which clearly predated Docker in the first place, and container orchestration. And if you look at where, like the history, and I'm talking to a group that's probably already pretty well vested in Kubernetes, but if you look at the history, Mesos, Apache Mesos came out of Ben Hyman out of UC Berkeley, and it was because of the introduction to the Google Borg. So to a certain extent, it was the open source variation of Google's Borg. So it's really fascinating stuff. And Kubernetes, some people like to claim it came out of the Borg as well. It's not true, but obviously there's huge influences there. No real code moved over. And as far as me, I guess that's it. I've been doing this for a while. I started writing Java code in '97. It's been a while. A variety of different languages on that VM or the JRE. And I started teaching Go at a workshop in 2014 at Strangeloop. So I've been working with Go for a while, but I wouldn't say I was heads down on it until maybe the last 2.5 years. 2.5 years of just like 100% and almost entirely open source as well. So just like either a CNCF committer or working on Kubernetes, the core. Actually, I consider it a great honor. I had the honor of being able to participate in one of the Kubernetes votes last year on the steering committee, because I don't know if people are familiar with this, but you have to rank up a certain level in order to be considered a contributor or member of that. So it was actually a surprise. I had no idea. I got sent an email and I was like, oh man, that's okay, great. Then I vote for you. So with that, should I start presenting? Is that where we're at?
Sounds great. Go ahead, Ken.
All right.
Thank you.
Awesome. So where are we at? Here we go. How about this screen? I got a few of them up, but so I was asked to show off Cuddle, which I'm happy to do. I'll throw out there that it's probably worth stating two things. One, first of all, Cuddle kind of was an accident. It came out of our interest in building out KUTTL. KUTTL is the Kubernetes universal declarative operator. So if after this, there's some conversations around operators and around that space, and you can go all the way. I also, how long has that been? Maybe 9 months or so, maybe a little bit longer. I'm also a co-chair to the operator SDK. So if it's anything in controller runtime, I often meet up with the API machinery team. So at the core of Kubernetes, the operator SDK, of course, KubeBuilder, and then all the way out to KUTTL. So I've been working in the operator space for a solid 2+ years now. So if there's any questions in that space, that'd be kind of fun to talk about if you're interested. I did a presentation at KubeCon last November, so it seems like forever ago now. And that's what I have as far as slides. The presentation's out there as well. Many of the jokes I've probably forgotten. And I'll probably take it a little bit more casually than I would normally. So probably more code focused. And I'm happy to dive into more of that as well. So why don't we just get rolling? I also have some backup support here. We'll see how this goes. Let me project this in. I also have a new machine, so it's a little bit crazy. You can already see that I don't even have rights to edit anymore, so it's a little sad. It's a sad time. Oh, that showed up on the wrong screen. Sorry, let me see if I can figure this out. This is PowerPoint, that's why. That's gonna be a problem. All right, well, maybe we'll just flip these slides like this then. That's fine, I don't care. I was making jokes around, I can't even remember his name now, Foghorn, thank you. Because he was the first character that came to mind whenever I thought of declarative, where I thought he said, I do declare. The funny part about that is I think that might just be me making it up. So there was a little bit of fun with that. There's how to get a hold of me, just Ken Sipe on Twitter. Also, if you hit up on CNCS or in the K8 Slack, I'm also Ken Sipe, and I'm there most days, so including weekends and such. We'll go with that. So what is Cuddle? Cuddle is the Kubernetes Test TooL. Of course, we just made some name up that made sense, and this is what came out of it. I actually quite love it. Frankly, out of all my work working on KUTTL, which is where Cuddle came out of, I think Cuddle is my favorite. I don't know if I even have the same passion for KUTTL as I used to. I do for operators as a whole, but Cuddle, the number of people, the interest in it, it really should be high, and it's slowly building. We'll talk to that a little bit, but it has a huge audience or people that would fit the category of people that would gain benefit from it, if you will. It originated, as I mentioned, from KUTTL, which is an operator. And since we were building out an operator with the premise that we wanted to be able to build out an operator through declaration, it just made sense that we wanted to also be able to do declarative testing. And we'll talk about what that means here in a second. Now, the funny part is that people keep asking for more than declarative testing. So we'll talk about kind of potentially the direction we may be going as well. But where does it fit in? There's two places where Cuddle fits in nicely. First of all, it's clearly not for unit tests. It is either for integration tests or for E2E tests. Now, what do we mean by integration tests? It's probably not what you're thinking. When you get into building out, let's just call it a Go application, and you have a unit test, and then you have an integration test where you might need to stand up a couple of elements of the infrastructure in order to fully test out further. Some might consider that an integration test. What we mean by integration test in this regard is you have KubeBuilder, meaning you have SED. Well, you don't actually, technically, you don't need KubeBuilder. You do need SED and potentially the API server. So essentially standing up Kubernetes without any controllers, right? No control plane whatsoever. And so there could be some value in that. We'll talk about that in a little bit. And then we have end-to-end testing. So end-to-end testing, meaning I really have a full Kubernetes cluster and I want to be able to validate things. And I'm probably testing through paths in your controller logic. Now, there's some problems with that. There's challenges if you have states of things that change frequently, if they're not driven by, I'm missing my train of thought here for a second. The core of it is this. What I'm trying to say is that you're testing the eventual consistency, and that idea sometimes escapes people. They don't fully get it. They don't fully understand it. It is, if you have an environment that's like a Kubernetes environment where you have flaky tests, almost always those flaky tests are built, are based on the fact that somebody was trusting on time. They put a 5-second delay, and that's got to be plenty of time, or something along those lines. And that is not a good design, not with this tool chain. So whatever state your cluster, your controller, or your Kubernetes object will eventually get to, and not an in-between state, but the end state for the current situation, that's the thing you're testing for. So, and we can talk a little bit more to that. Now, if you have control over your controller and you can step through your controller, now there could be some things there as well, but we'll leave that to some Q&A time a little bit later. Okay, so what do we mean by declarative tests? You know, just to shortcut to like an example. Well, that's it right there. We'll talk through a lot of this, but anybody who's been in the Kubernetes world would recognize this. It's a YAML file, a manifest file. It has your standard configuration, which would be your API version, your kind, a name. You're basically the minimum necessary information to be able to deploy a thing. In this case, that thing is a pod, but it doesn't matter. It's any Kubernetes object, right? Any kind. Now, the beauty of that is it literally is any kind. And of course, if you're familiar with CRDs, you could change the kind of things that are available. And so you could test those things, which is very commonly used within KUTTL. Now, in this, I have slides that go through this in more detail, but if you look at this particular example, you'll see that this is 0.0 install. And so that is also meaningful information. Now, we get into an area that's really challenging. I'm also making some huge assumptions. And the assumption is that you have a general idea of what a test looks like. So to give that away a little bit, just to make sure that we're absolutely clear, you know, in the vernacular of, say, maybe JUnit, you have a test class. You have a class, which is a test suite. And that test suite has a number of tests. So every function usually is a test. And then you have like these hooks, if you will, lifecycle hooks. So you have like before class and after class, and this would be setups before and after the whole suite. You could have a setup and a teardown, and this would be before and after a given test. And so we're going to use some of that vernacular, but we have it because we are working with files and not with methods. We have to be able to come up with those mechanisms in a slightly different way. But we also want the freedom and the beauty of being able to work with manifest files. Now, to cut away real quickly for a second from the presentation, I want to point to the Kubernetes proper. So I don't know if you see this out here. I'm out at Kubernetes on master. I would zoom in. There we go. I don't know if you can. I don't know if that works in our presentation world, but I'm right here, Kubernetes proper. And what they have here is, let me go back a page. What we have here is a bunch of shell scripts. I've got a directory, which is a test directory of a bunch of shell scripts. One expects that this is for testing. I have this test for crds.sh. You know, I have tests. Now, there's so many things to pick apart here. Now, first of all, you know, let's not be cruel. There are tests. That is awesome. The fact that we have tests is a really wonderful thing. So we don't want to bash on this too much. But we could look at this and go, is this the right tool for the job? And does it have some negatives to it? And could we make it better? So first of all, this is shell script, and it really is a bunch of conflated things together, right? Like it's a YAML file or a manifest file that's conflated inside of a shell script. And I got to know, in all likelihood, I'm bringing including things from in the environment. I have to know some interesting nomenclature if I'm writing this for the first time myself, if I want to add another file to this particular directory of logs and things of this nature. We could ask a very simple question, which would be a standard and easy question when we're dealing with asserts, and that is, how do I assert anything? Right? Where do I even start? So maybe you would just search for an assert word and copy and paste and use it as a template. Lots of questions. Is this YAML properly formed? Well, if it's checked in and it's been running, one can assume that that's probably true. But you can imagine the challenges of needing to add an element to this file to be able to verify and test against that, or create this for the first time myself. and making sure that and look at it as well. It's in JSON format, which is totally fine, but is that the format that you're standardly working with Kubernetes objects? And some people are, but most people probably are not. They're probably working with YAML files, and it just gets complicated, right? This is the stuff that I'm super glad that it's here, but I think we might be able to do something better, and that's where Cuddle fits in. That's our hope, anyway. How do we assert a thing? Well, there it is. Look at this example. Now, I'll flip back a second. That was the manifest file for installing. This is the file for asserting. What are the things that are true? Well, first of all, we know the file is named assert. We also know it's the 00 file, and we could guess at that point, right? This is the assert in the assert phase after the install. Still questions, though, right? Notice also this is a fragment, and that's awesome. Like, this isn't the full output. And as anybody who knows who went from like anything pre 117 or below and then moved to 118, that output just exploded with a bunch of managed fields. And we don't have to copy all of that. Why would you want to? So you have to be slightly aware here. It's not completely complete, right? Like it's a fragment, but it's the fragment that I'm interested in, and also, and this is important, it is the fragment by which I'm asserting. Now, anybody, and since we're talking with the Kubernetes meetup group, and I've already been told that you guys are, on it, sharp, which is awesome. Anybody in that category would know to uniquely acquire a Kubernetes objects, I need the GVK, right? I need a group version kind. I need the named thing. So everything above this is the ability to identify a thing, and then anything else is going to be included in the assert. So in this particular case, we would say that there is a phase inside of status and that it is running. And we'll play around with that a little bit when we start running some examples here. Also, we could extend that a little bit. So what if, like, during an assert, you just happen to be working with something, if you've ever worked with namespace, especially like deleting things, right, where you have finalizers involved, those can take a long time. So if you have an awareness of that, there's an expectation of that, we can also augment the information in here. So we have one manifest file, but this manifest file has multiple instances of objects, and we've included something called the test assert, which we'll talk about a little bit later, which allows us to make some changes to the assertion process in this particular case to maybe change or extend the timeout associated with this. Now, Cuddle is completely built with the expectation of eventual consistency. So there is no such thing as eventual consistency when you're asserting something to be true without having some end time for which you expire, right? So there's some default values, and we can have then changes with that default values. There's some maturity we could probably go there as well. Hit me if that's a question for you. Just hit me up a little bit later. We'll chat about that. So that is Cuddle. At the heart of it is this harness for testing out things in Kubernetes. Now, where I have found, even though I talked about two different categories, I talked about integration tests and I've talked about end-to-end tests, where I have found Cuddle to be heavily used, where I get the most interest, is in two groups, which you might call the end-to-end testing. One is that I just want to test this newfangled thing, whatever that is. All right, so that's probably your standard. And in that world, what happens is things are created, things are asserted, and then everything's tore down. The other story or use case that people tend to use Cuddle for is a verification process, where I literally use Cuddle to stand something up, and I assert that it's true, whatever the state of the cluster is. And then you can put in some flags that basically says, don't destroy this. And then what you have is the ability to create a cluster, to stand it up in exactly the way you would expect it, and to leave it standing, and to assert that the conditions of the cluster are valid. And so there's a number of ways in that second use case where that's used. One is to always stand up a cluster in the exact way that you want it to before you start, like testing something else that you want to test out manually, or before you hand it off to a customer, or things of that nature. At day 2, what we commonly did is roughly monthly, we would do these what we call mixed workload tests, and we would create a cluster out. It varied. We did it on all of the cloud providers, but most often it was on AWS, and we'd have like 5,000 cores and 120 nodes or so. And we would just need to stand this thing up and assert that it's in a certain state for us to start. So that's kind of where Cuddle might fit in. It's an example. All right. I actually, as I mentioned earlier, I ended up joining as a co-host to the Operator SDK meetings, and that was largely because I had a bunch of people from Operator SDK go, "This Cuddle thing's kind of cool. We should use this." And I got sucked into that environment because there's a bunch of great people in that space. And today, the Operator SDK has something called a scorecard, and they wanted to extend that with new features. Well, that extension now is Cuddle. So Cuddle, if you learn and understand Cuddle, that is what we use in the Operator SDK for testing, as well as you could use it outside of the Operator SDK. Okay, so how do you Cuddle? How do I get started? Well, first, you could just do a brew install if you're on a Mac. The other is that we do a job of making sure that we do a release on crew as well. So if you're used to Kubernetes crew, where I can go kubecuddle, crew, install Cuddle, whatever the latest release is, and you'll get it. I think the latest release now is 0.90. I'd have to check. I don't know. It's been a little while since I've actually verified that. So it's only a handful of things that it does. Of course, you can get the version and the help. We're going to forget that for now. The main functionality is underneath tests, and we're going to go through some discussion on that. Eventually, I added in the assert and the errors, but the assert, why? Well, you know, the most common way of creating a Cuddle test is to actually want to assert something, and oftentimes you're doing that manually, trying to set something up or evaluate something, and you just want to assert something without going through the entire test suite. So that's what the assert function does. It's a great way of just saying, I just want to assert this state of things to be true right now. So it turns out to be a really great add beyond the workflow. If we get into a Cuddle test, there's a number of capabilities that it has. If you just say Cuddle test, it will look in the current directory for a Cuddle -test.yaml file, and if it finds one, it will just use that as the point of reference, and it will do whatever's in there. So in that YAML file, which we'll look at in a second, you could have like the whole test suite that you have, any kind of timeout values that you have. There are some things conflated there that I'd like to tear apart or tease apart. Again, I'm happy to go into those details if you'd like. The concepts have kind of evolved, and now it's very clear where we need to go. You can reference it with the --config. That's, again, if you want to name it something other than this. We do this within the Operator SDK, where the test file is not a Cuddle file. It's just it's a different file name. I don't remember what it is at this point. You could just say Cuddle test and then pass in a directory. Now, as I mentioned before, unlike JUnit or Go tests, this is not a programming language. It's a set of manifest files. So we would naturally point to a test folder of files or a test folder of folders in order to create tests. So expect that. But that's what this is doing, is it's taking defaults. It doesn't have a configuration file, and it's just going to point to this directory and start executing things. And we'll talk a little bit about that. Every flag that you see is possible to configure in the this file here, in the configuration file. Or you can do it on the command line. It will run completely on the command line without any other configuration if that's your desire. There is an expectation, clearly, that we are able to get to a Kubernetes instance, though. Now, let me pause for a second. Cuddle was built, and it includes kind. So it is capable of standing up a kind instance if you pass in flags to say that you want that. The assumption is that you don't want that. And I actually prefer people don't use that. I actually think we should pull it out. But so my expectation is that you've stood up a cluster somewhere, and that your current kube config, or your current kube config points to that cluster, and then Cuddle will find it and then start running against it. These other flags, the CRD dir and the manifest dir, these are like preconditions you want installed ahead of time. The only difference between these, frankly, is that CRDs, manifest files are just applied. CRDs are applied and we wait for it. So that's the only real difference between those two, is that there's a wait for the CRD to take effect, which oftentimes takes some good amount of time. Depends, of course, on all kinds of factors. What's that?
Yeah, on your you were talking about kind and taking it away as far as kind of like, I guess it was a default or whatever. You're not saying that kind is not a good
Oh, no, not at all. No, okay. No. I love kind. I use kind. I've switched completely over from Minikube to kind. Kind's awesome.
Me too. But I was wondering if you were just saying that it was just, you were just saying that, hey, do your clusters how you want them, and then use the context to switch. Okay, thanks.
Yeah, I think conflating the two sounds like just right. Like you just like, this is a test tool, not a cluster bootstrap tool. It's kind of weird.
Yeah, that's exactly right. I can't tell you the number of times that's actually caused some confusion. It actually created this desire, like people were submitting issues, to create a cluster of a different I hate to use the word kind in this context, but a different cluster, like an AWS or an AKS cluster or ETS. We don't want any business. We're not in that business. We don't want to be in that business. And that's for Terraform and other tooling to manage. Our focus is not that. So, but we love kind. So to Paul, we're big fans. So, what else? There's a couple of things that came in fairly in the last year, half a year or so, that I really like pointing out. And this one, the operator SDK group pushed us on this, and I actually love that it's there. If you pass in a -- report, you can pass in JSON or XML, and if you pass in XML, it actually gives the JUnit XML file. Now, the reason why that's important and useful, why follow JUnit, it's because all CI tooling will report that in a really great format. If they support any reporting at all, they integrate with that. So it actually ties in and adds great awesomeness to like Bamboo and Jenkins and all that stuff. So really, really cool thing. It's actually kind of nice as well, without that other tooling. Okay, so let's walk through like the concepts that I just kind of like hand waved over a little bit. The first is that we have this thing called a test steps, and the steps are the files, and the files are in some ways awkwardly numbered, right? They're index numbers, and the indexes matter. There are some naming conventions that matter. We'll take any YAML, so YML or YAML. My preference has always been YAML, so you'll see that as examples. We ignore other files, so if you had a README file or a license file or something like that, it's just ignored. So that's kind of nice. You can see the nomenclature here: index dash step name, and those names actually do show up. One, they show up in the reports. Two, they show up in the test log. So those the step names matter, and there are some names that also matter. So the two names that matter, that are kind of reserved, if you will. One's assert, and the other one is errors, a plural version, a plural name, errors. So in this particular example, you see a 00 pod, you see a 00 assert, you see a 01 staging. And so the way this works is anything in an index that is not an error or an assert is going to be applied during the apply phase. So we'll just apply it all. After the apply phase, we will enter into an assert phase, and the assert phase will assert that the assert files are true and that the error files are not true. So the errors is it's a way of asserting something to not be. So that's the idea. We will not leave the assert phase of, in this case, the 0 index. We don't leave that until one of two conditions are true. It either asserts to be true, all of it, or we time out. if it asserts to be true, we will then walk to the next index. And so in this particular example, you see an index 01 staging. So that's the idea and concepts. There's a lot more concepts to go, but that should get us started. I think I might have to, this is super important and sometimes confusing to people. Anything happening in the apply. Well, when we apply something, if it does not currently exist, it will be created. Now, that part's not confusing to people. However, if it does exist, it will be strategic merge patched. And that can be confusing. Now, the beauty of that is it allows you to, let me go back a page real quick. It allows me to do things here declaratively in my pod, where I'm a little bit verbose because I have to be complete. But it allows me in my next part of my next step, if you will, it allows me to be terse. It allows me to just basically name the thing so it can be uniquely identified, and then describe the one or two things I want changed or augmented about that object, and that's it. I don't have to be, I don't have to express all the things. Now, we haven't talked about this yet, but there's a couple of different ways that KUTTL works. The way it was built to work is that it will have control, it will have, you could say, cluster admin rights, and it will create namespaces, and those namespaces become the isolation, the test isolation. So I can run a bunch of tests concurrently because they're all isolated in their different namespaces. Now, there's a number of places, a number of organizations that you probably don't have those rights. Or in the case of Operator SDK, that was not a standard model for them. So we do have the ability to run within a namespace, but within the namespace, what could happen is you have a different test starting up for an object that was created in a previous test without a cleanup. And that can be problematic for people. So that's, we're giving you a heads up, a warning where I see common misunderstandings. That could be good or bad, right? Like it's nice to be terse. It also might be nice to be able to ensure that we have proper cleanup if that was what was intended. When we live in a space where you are confined to one namespace, the cleaning up of things is no longer in KUTTL's wheelhouse, it's in the test designer's wheelhouse. They are the one responsible for doing it because they're the ones that live in that space. Now, that's another feature I'd like to add into KUTTL. It seems fairly easy to me to add labels to be able to select on and provide some deletions. But then again, when you're living within one namespace, you also run into this problem not being able to run concurrently because you could have collisions and such. So anyway, we could, again, if that raises questions, bring them up. As mentioned, we have an index file with an assert, or we have an index with an assert YAML, or we have an index with an errors file. That's how we assert something to be true or assert it to not be true. So some terms that are really, really helpful. So first of all, we have this term that doesn't exist yet, but I'd really prefer to call it out, and that is, I'm going to call it a test collection. Right now, it's a test suite. The test suite is a YAML file. We do refer to it as a kind. You'll see YAML files with that kind defined. That can be confusing, only in that it's not a kind that is defined within the cluster. We use the same nomenclature that you're used to working with Kubernetes inside of a cluster. We still define a kind. It is never really applied, or we do not have a CRD to define that kind of object within the cluster itself. But we have a test suite. The test suite is a collection of tests. The test is a collection of test steps. The test step includes two phases, essentially the apply phase and the assert phase. And within the assert, we also have the way of defining something called a test assert, which allows us to change or augment things. So some simple examples. This is where things are conflated a little bit. I'd like to tease these apart a little bit. But here, if you look at this folder layout, I have a folder here called test data. We have a number of folders down there. So this is the test suite. This is the test, the CLI test, the CRD and step tests. These are test folders. The test suite is a collection of test folders. We also have something called the test suite, which is a kind, as I mentioned before. So we have a V1, Beta 1 of, and this is under the KUTTL now. This is an older image, but KUTTL dev, V1, Beta 1 for test suite. In this, we can define a number of test ders. So, and beyond that, you can, as you'll see in slides, I can also refer to a tarball. So it will just suck down a tarball as a tester as well. This start control plane, this is what I was referring to previously. This, if I said true here, it would stand up a kind cluster. Again, I prefer people kind of deviate around that, but that said, it has nothing to do with kind at all. It has to do with who's responsible for what. So tests, I mentioned before that this is the test suite. This is the test folder. The test folder can have any number of steps to it. In this particular case, there's one step, and it is probably the installation or creation of a pod, and then they assert that that pod is true. The test names, the folder, the test names actually show up in the test suite as the name of the test. So those are as if the traditional tests. There is a way to augment that or change that through metadata, but by convention, that's what's happening. The test step. Now, with a test step, it is literally just a declarative file, like a manifest file, as we talked about before. But oftentimes you may want to do other things. And one of the things that's very common is I may want to apply something. Now, there's ways of doing this without using the Kubernetes, without a KUBECTL apply. I'll show you an example of that. Where you would most likely use this command is, let's say you want to do a Helm install. So I could do a KUBECTL Helm, or I'm sorry, a Helm install, blah, 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 or a release, and what have you. So that's probably the most common thing to see. The test assert, as mentioned before, if I wanted to reduce the amount of time, the default is 30. Here I've changed it to 20, and this is included in my assert file. So it would make sure that the status has a quality of service class of best effort. This would have to be true for this assertion, and it would have to be true within 20 seconds, otherwise this fails. When I run the KUTTL test suite, as you see here, it's a plugin. I say KUTTL test, and I pass it to the directory I'm testing. It will then do a startup. It will provide an output of what's going on, and then it will essentially show you each step it's making through the test. I mentioned this already. Namespaces are designed in KUTTL to be our way of test isolation. If that is not a possibility for you, you could run it all within whatever namespace that you want. At that point, you take responsibility. You're the one that has to, one, make sure the test is designed and works for that environment, but also the teardown, you're responsible. Now, you can do the teardown within KUTTL. You could have something that will delete things, and I'll show you how to do that, but you would be responsible for doing it. If we were to build out our first KUTTL, what would that look like? So we'd make a directory. In this particular case, I make something called Doghouse, because I was making fun of Foghorn at this point. We create a YAML file that basically says, hey, I want to create a pod that's called the Doghouse, and I have Nginx in it. I then say I want this thing running. You know what? I don't know why I'm showing slides at this point. Let's do, you know what? I don't know. Let me do this. Go to each play. I told you I was on a new machine, so this is going to be interesting. Let me code this, and hopefully we have the things we're looking for. Here we see I have the Doghouse, I have the insert. It's all the things we were seeing on slide. Let me jack that up a little bit. And let me jump to KUTTL. We'll do this real quick. Now, in this particular case, I don't actually have it installed, so we'll just do it right from code. It shouldn't matter. And oh, great! I told you my other machine was busted, so I'm on a new machine. So I'll talk through this while this is downloading things. I probably should have just installed. Let's walk through the henhouse for a second. That's kind of funny to say, in fact. What's different about the henhouse? Well, first of all, the henhouse for the install, I mentioned you don't need to do the KUBECUTTL. You can actually just say apply. So this has been added in where I could have a test step and it will apply. You can then, have any number of files that you could apply. The value of this is that people kept repeating this, the copy and paste issue, where I'm using the same file over and over. I could also do something. I could have this in a common directory, let's say. So I could reference it this way as well. So I have something I'm commonly using across a lot of my tests, and I want to put it in a location that's convenient. That would work just fine. What else? I could, of course, run commands, and I could put timeouts on those commands. With commands, now I won't remember the details here. We'd have to look at the docs or code, but I have the ability with commands to say, hey, this is sensitive, so don't put it in the logs. I could say also that this is a background. So you wouldn't do it here, but we do have commands that I could put in my YAML file. I'm sorry, in my KUTTL control file, and I could have backgrounds. So what will happen is it'll be spun off as a process that's running in the background, and then it will continue running tests. Now the value of that is that is a very common way that we would actually test kudo. There are two common ways that you would test your operators. One is that you would test a released operator. In that particular case, you would just install it the way you would normally install it. So for us, it might be an apply. But when you're testing something that you're in development, so you're in your CI environment, you're running it straight from code. In that particular case, you want to run it as a background process. So you're spinning up a controller that's going to integrate into the cluster, and you're running it as a background process. And so we needed something like that. So that gives you a little bit of insight into that. With the Assert, probably one of the last things added last fall before KubeCon was this thing called collectors. With collectors, the idea of a collector is, as you see here, it's a property of a test assert. And what a collector is the thing that you care about most when a failure occurs is to understand the context of that failure. That oftentimes is what you're after. So what a collector does is it gives you the ability to get information only if an assertion failure occurs. So in this particular case, what this says is, if this test were to fail, get the logs of the pod that was running as henhouse. Now, of course, if you have multiple containers, you would have to specify the container. So we have the ability to specify a container. Of course, you might want to actually run a command. And so the thing you want to collect is whatever your command is doing. So you could actually run a KubeCuttl logs and get it yourself. Or you could run, so the things I believe that we have collectors right now is either commands, so give me the output of commands, pods, and events. So those would be the things that you probably want. Let's see if we have everything. Good. Uh-oh. Great. This is what happened. Okay, so in just in this kind of thing, right? It's going to happen. Let's do a crew install of KUTTL. Let's see if that works. First of all, I got to spell it right. I thought we were presenting here. Somebody was supposed to capture that. KUTTL. Yay. Okay, so back to where we were. There it is. Yeah. All right. Oop, I forgot one thing. We want to say test. We have it. I just screwed up. Edit that recording, please. Where are we at?
It's real, folks. It's real.
It's real. Just my controller. I think here, let's do it this way. Let me jump to my, we could talk about it. There isn't a thing we can't talk about. So if you feel like, hey, what the heck did you just do there? And it concerns you, just let me know. We'll walk through it. I think we should be able to do that. It's connecting. It's now spinning up pods. the issue that, the reason why the failure was there is because I did have a KUTTL YAML file within that folder, and it was like, hey, you're trying to run this without a controller. Are you sure you want to do this? And it failed. So in this particular case, we had a failure. I'm not sure why yet, but perhaps we will look through the logs and find out. That wasn't part of what I was trying to show off here. What I do want to do, what is succeeding here? The doghouse. Let's go to the doghouse and go to our assert and just like change something like that. So it's misspelled. Come over here and say run. And we should then get a failure on the doghouse. Now the problem with this failure, and oftentimes when I'm showing this off, I might do something like timeout is like 10 seconds, is that we actually have to wait, right? You have to wait for the proper timeout. Oh, the failure that we're having in the other test is because the version of Cuddle that's released isn't up to par with what I have in that configuration. So that's something we can easily fix too. So what do we get? I just broke the doghouse, and there are two things we could look at. There are two errors that get outputted. The first error that you get is this really lengthy diff. And notice the diff here. It's basically saying, you have a manifest file that doesn't have any of these things. So I've got, you know, this F spec and this F containers, essentially all this managed field stuff. So it's like, hey, you didn't declare this and it's here. So is that okay? I'm not sure. So that can be very, very verbose, but sometimes you want that. The last thing it does though is this error right here. You can see that the resource was the Cuddle test selector. It of course creates some crazy interesting name, but it says the .status.phase, the value mismatched. It expected runing, and it did not equal the actual running. This particular example is exactly what we were looking for. This is the failure, is that this is wrong, right? If we wanted to fix the other, I would be guessing now, but in here, maybe collectors isn't here. Maybe that's it. I'm not sure. I hate guessing, but let's guess and see. I'm almost positive it's because I have a configuration that's off. We'll hunt for it a little bit later. Hopefully you can forgive that. Contains an object unstructured in the install. Okay, let's go to install. Well, we found it. Put that back then. Let's see if that will run. Nope. Okay, not a big deal. Hopefully you can look past it. Like I said, I don't have my environment completely set up yet. I think you get the point, or I hope you do. What else? We're going to run out of time, so let me show off some of the things that we really want. First is Cuddle always expects a test collection, right? A test suite. But sometimes you only want to test a test. So you just pass in --test doghouse, and it will just run the one. Oftentimes there's a lot of configuration or setup that's necessary for the whole suite. But again, you may only want that particular test. So that's how you would do that. What else? We got steps. This is how I would delete things. So this particular step is deleting some stuff. You can delete something by a GBK, by the exact name. You could delete something, in this particular case, all pods with this label. Or you could say, I want to delete all pods. Now, again, you're deleting all pods within the namespace that you're currently executing, whatever the context is. But there's a variety of ways of managing the deletes, and hopefully is sufficient. If not, let me know. Here I'm doing an apply, but in this particular case, I'm pulling it from a URL. Here I'm doing a kudo install of a given particular thing, so I can do operator oriented things. I can define the namespace. In this particular case, as soon as you give it a namespace, you basically are not creating namespaces, right? Like you can't have both. So in this case, you're saying, I just want everything run under default. What else? We have the applies. We can do the same thing with asserts, where I have the same thing I'm asserting over and over again. We can actually control, here I can actually control or assert events to be true. This event should happen, which can be very useful. We talked about the fact that we do use CRDs. Now with CRDs, when you're doing a startup, and you want to wait for the CRD to be true, that's a great time to do it. But sometimes you want to go through a number of tests, and then you may want to either change the CRD or you want to add a CRD of some sort. That becomes a little bit problematic. So the reason why I say that is you want the proper wait time. You want the wait to verify that that type is there before you start to use it. So the way to do that is that you would have assume that a 0, 0 apply is actually creating the CRD. The 0, 0 assert asserts that the CRD is there, that it has a status, and give it the proper wait time, of course. And then the 0, 1 is now you could start to use it. So just organizing your files in the right way will give you the ability to have a better experience. I'll put it that way. It's kind of fun. Here you can see the Helm inits and installs. Of course, this was using Tiller, which is no longer part of the equation if you're up to date. This is a fairly new feature as well, where I could say KUTTL test, where I actually pull it down from a URL. So this, I demoed this while I was at KubeCon. Just trust me, it works, assuming the format is correct for the version you're using. Now, the idea here is that you might have versioned tarballs of tests. And how great would it be that you can ask your customers to run a suite of tests to verify that their environment is accurate? And there's no reason why I couldn't have a tarball full of asserts. I could just have 0, 0 assert, 0, 1 assert, 0, 2 assert. So a number of asserts without any applies, assuming that they've done the thing that you wanted them to do, or you have an operator or controller that's driving it, or what have you. So the idea here is that I could pull down tarballs for a given version of a thing, and then assert an environment to be correct. Also, as I mentioned here, we can have that included within the testers. So it goes a little bit beyond testers at this point, but I could add folders and URLs, and the URLs be fetched. Those are exploded on a temporary drive, so you'll need the ability to have a temporary drive. And then as we start to have environment variables within these files, they can be expanded, which would be problematic if you are running right out of the tarball in memory, which we do not do. What else? We talked a little bit about collectors, pods, and there's an example of reports. There's some more examples of things. There's how to get involved with the project, and there's some older numbers. So I believe we're on KUTTL. If we're not on 090, we're on 080. So we're definitely at least one version past that, and there's where to get involved. All right, so been talking for an hour. I'm gonna just let people ask questions.
Oh, I've got some questions. So first of all, I can definitely see a lot of the value of this as somebody who's written a lot of operators. I mean, I wrote operators before operator SDK exists. I think the first operators I wrote were with raw client Go for like 1.8 clusters. So
good times.
Yeah. Oh boy, that was fun. I still love client Go, just not for operators.
Well, we still use client Go within
under the hood.
Yeah. Yep. There's higher level tools for sure, but it's still involved. But yeah.
Oh yeah, no, definitely. It's just nice not to have to write the controller everything from scratch if you don't want to. Yeah. So a few things. How do you assert that you have deleted a field or a resource, like rather than additions and modifications? Because a lot, I didn't see like how do you declare like here's a YAML file that shouldn't exist? Is that just metadata?
Yeah, I have. Let me see here. I have more experience asserting that something is not a value. So maybe I'll show that, and then maybe we'll take a look at.
I can look it up, but there is. I guess the question is are there also ways to kind of assert that you change this thing and then this other resource disappears? I assume there are. Okay.
Yeah. That's what happened. I went into full mode here, and that's okay. Yeah, go ahead.
Similarly, a lot of the operators I've written are for effect for third-party systems, right? So, we've got an operator that makes Grafana.net dashboards, for example, based on CRDs.
Mm-hmm.
Are there asserts for run this command and take the output or diff it to, like, I want to make sure that when I made this Grafana dashboard CRD that there is an actual associated dashboard in this other API.
Yeah, I love it. I love it. So one of the last, so first of all, we within KUTTL and KUTTL follow KEP process. It's a modified KEP process. It's a little slimmed down. But the last thing that was added as a KEP is command asserts.
Oh, neat.
So this is I don't know if this is released, but it's definitely been implemented. And what it does is similar to what you're describing. I can basically run a command, and if it comes back anything other than 0, it's a failure. And then we want to go beyond that. Where my head was is exactly where what I think you described. I want to be able to do a regex assert on a pod's log, or potentially off of a command, and assert that the regex matches or doesn't match. Yeah.
Okay. Yeah.
Like if you're working with maybe Cassandra or Kafka and you want to assert that something out of the controller log has been initialized, you just need a way of doing that, right? Or that the garbage collection occurred or something along those lines. So yeah.
Yeah, and a command is a great like escape hatch for that. That's why I kind of went there. It's like, I don't expect you necessarily to get too detailed in anybody's tests, but I can, pretty easily write a curl and make sure that a thing exists or doesn't exist and pipe those into greps. And you can also, once you got a command output, you can kind of do anything you want for checking that.
Yeah. Like I said, I'm almost positive that, there you go. Oh, someone merged that? This has to be undone. Somebody screwed that one up, I think. Oh, no. Okay, this is good. Yeah, the gentleman that did this was so awesome because it was a contributor, an open source contribution that called in and it's like, hey, can we get this? Like, yeah. And then anyway, he did a great job. We walked him through it. My criticism, which was inappropriate, was that he also wanted to move. I asked him if he could move the KEP to implement it, and he basically changed the folder, which is not what we do. So this is wrong. I rejected it. I just thought someone merged it behind me, but it's not true. Anyway, we'll get that resolved. That's implemented. It just needs to be released. It was just recently implemented.
So how does this compare to like the operator SDK? So I'm going to keep, someone else asked questions that I did a 3-hour talk about writing operators in the Go meetup here. So I've been in, this is my world. So somebody stop me if I'm going too far, but how does this compare to like the operator SDK has some rudimentary testing things that they want you to use. And there's also like the entire fake client Go. I guess I can see how this compares because this is real, right? And it can be very hard to fake out things. I guess my question is, as somebody that's in there a lot, do you see this being the more common thing? Do you, like, operator SDK obviously loves it enough to pull it into the upstream project.
I think they're complementary a little bit, and if I have in mind what you're describing, solely in the like KubeBuilder space, along with Elena, built out something called Test Environment or Test ENV. It's still that is super useful. It adds a lot of value. The part that I left out of the conversation because it just wasn't germane. But when you're building out controllers, there's one aspect of it is the controller. Any reasonably productionized operator is also going to have some webhooks. And whenever you're dealing with webhooks, now you're in the space of needing to deal with like SSL certs and certman and a variety of other things. So the test ENV provides a way of getting around some of that in a what I would call an integration environment, but it doesn't test it out in a full cluster environment, right? So that's where KUTTL fits in, is I can actually test it in a cluster. It's a little bit more real. It's not just to the developer environment. It's actually a cluster. And so now the cluster is configured correctly. It has certman there, has the webhooks integrated correctly. I don't know if I mentioned this or not, but very early on, we had people picking KUTTL up and needing to test it up against GCE, and we were missing some of the things necessary to make that happen. That's all integrated in. So we have people running this against GCE as well as Azure and AWS as well as Kind. So all of that is possible.
Okay. Well, yeah, and I guess you bring that up. I could definitely see the value of being able to run that same test suite with 6 different kube configs and different providers to, test out your operating.
Well, that's the other thing too. Yeah, yeah, that's the other thing, right? Is that what if I have one suite of tests and I want to test it up against Kubernetes 117, 118, 119, 120, and then on EKS, and yeah, so
your matrices figured out.
Yeah, exactly, and that's not something a developer is going to do, right? And well, if a developer is going to do it, they're going to build it into their CI environment or somewhere later down their pipeline. It's not part of their dev environment. So, yeah, yep.
Oh, I like that. It's very exciting. I'm gonna contradict you. K3S and K3D are awesome, and no, I'm just kidding. They're both fine. They're both totally fine tools.
Touche. That's awesome.
So
K3S and K3D are less comprehensive.
Yeah. Quick question for you, Ken. On the KUbuilder side, the test ENV and such, as you know, they use the Ginkgo, BDD type stuff. Some people really like the BDD style. I don't see that kind of in Cuddle. Are you thinking of having more of a BDD approach to it or not? Or, what I'm trying to say?
Well, can you explain BDD for the uninitiated? Sorry, that's a new term to me.
Is it behavioral design, driven design?
Behavior-driven development, yeah. So first of all, I'm a big BDD, well, I shouldn't call it that way. I'm a huge user of, in the Java world, of Spock, which has a lot of BDD driven off of Cucumber and JBehave and all that other stuff. Yeah. So Carson, I don't know. Defining BDD, behavior-driven development, the idea or concept, as best I can tell, is that you could have use cases that have more of a user-oriented feel or description to them, like an assert is based on an expectation a user would have. And then oftentimes BDD commonly will try to have reports that are human readable kinds of reports. And I'm not sold on any of that. I just am not. I've never seen that successfully implemented. I think it's a lot of pie in the sky type things, to be honest. We capture, I don't know how to answer your question exactly. There are some things within Spock that are just too amazing. Having a groovy tool that then kind of does I'm going to throw out a bunch of terms that may need to be defined, but some AST transformations that allow you to drive really crazy and great behaviors around tests. It simplifies test build out. We will likely not do anything like that because our whole focus is trying to be as close to Kubernetes as possible. Now, what we keep being asked to do, we keep being asked to put in things like, I don't know, like templating within the manifest file. And we've resisted, and in some ways, we don't even, other than CRDs, we don't really read this. Now, we kind of do, it depends. We do a strategic merge patch. There's some level of interpretation we provide, but it's very, very limited. And when we start going down this path, the problem that I'm trying to wrap my head around is, I get why people are trying to do it, but it makes this idea of having a versionable tarball of tests really hard. There would need to be a series of things that are predefined as part of pulling down that tarball. And so there's a bunch of metadata that you would force somebody to need to know. And I feel just haven't. Yeah.
Well, I can see exactly what you're saying. I see both sides. I think maybe you could take a more Argo style approach to that, which is if it can spit out manifests, we'll read from it. Because Argo is completely agnostic, and the end result is we just want some manifests, and I don't care what you use to generate them. So.
Yeah, we have looked at Q and Starlark, and we've thrown around a number of ideas, and I do like your last. That your main statement is, if it spit out manifests, we'll deal with it. That makes sense. We'll probably do something there. I don't know what that
point, right? And you can
do
a Helm template, pipe it into Cuddle with standard in, and you're done.
Yep.
other than you have no directory structure, that's the tricky part you'd have to figure out.
Do you know, Ken, when the actual operator SDK, Red Hat and KUBuilder will actually be merged in its entirety?
It's getting close.
Yeah.
The problem is that as operator SDK moved to merging in with KUBuilder, and that there was a movement that was a greater piece of work than expected around plugins, and it's that architecture that's causing problems. But I think we're honing. Well, and it actually goes beyond that. There were basically diamond of death dependencies on client Go, among other things that needed to be resolved, and then you had problems with just the advancements that were happening in the Kubernetes world. Well, yeah, I think we're super close.
Yeah. Also, it seems to me with the controller runtime, the backward compatibility. I mean, you look from 0.63, it broke at 0.68 and above. With I want a context here, or you have to put in a different thing in here at the bottom. I was just wondering if you thought that things will settle down in a bit or not.
I think we're finally getting there. I would have never guessed 6 months ago that it would have taken this long, but with the 1.5 release that just went out, I think we've got like a lot of the house cleaning chores done, and now we can focus on homogenizing things.
Because the V2 KUBuilder hasn't changed for a while.
Yeah,
it's pretty behind as far as what it's supporting. So. Yeah. Well,
the big change that's coming, it's just needing more support behind it, is who was that? I feel terrible for not remembering his name, but I think it was Joe. But there's a need to change client Go. That's the core of it, and client and it needs to change to support essentially server-side apply. And essentially field managed level changes. And where I left it was maybe November, December timeframe. There was an example branch out there on client Go that people were supposed to play with and give feedback, and then they were going to integrate that in. But that's going to be a pretty significant change. I mean, it's and unfortunately, I think most people are learning operators in a way that is not good. If they're doing good right now, they're fetching it out of the cache and then modifying, but that still falls into the not good category.
Right.
Anyway,
I have one more question, and I'm sure Carson does too, and others. But I remember what an operator that actually had kind of used the using KUBuilder, using the controller request duration to maybe an extreme. So let me say it this way. So we used it kind of as a timer cron, if you will, and so you could scale up, and it would maybe set a duration of an hour, and then it would then kick back, and reconcile, and then bring your number of replicas down. My question is, with Cuddle, how would you test something like that?
I don't know if I followed the actual test setup.
With the reconciler,
I do.
KUBuilder, you'd actually usually send back the controlled result with nil and such, but you can also give it a duration, right? Which you can say, hey, cue me back at a certain time, and then reconcile.
Yeah. So there are things that Cuddle's not good at testing. It's not designed to test, actually, and you might be honing in on exactly that. The thing you like to get the mental model correct around Cuddle, what you did, from what I heard, was to describe using your X-ray vision what is happening behind the API server. Correct. And what is happening in the guts or the belly of an operator or a controller, right? And so your mental model was all around like the control loop and queuing and requeuing and things of that nature. Cuddle is built wholly around Kubernetes objects and how you can describe them. Like this is how you would describe one. And the API server. And so what does the API server tell me? Now, if you think about the status of a pod, it will go through a number of different things, right? And the only thing you would ever want here is what one of those things are. If I put anything else here, garbage, that will always eventually, that'll be false, right? That'll be, now if I put something here, I don't even remember. Let's pull it up.
Talk about one of like the ephemeral phases, like
like pending.
Downloading.
That's what I was looking for. Yeah. So we could. This is a valid state. And it's in all likelihood, if I got to running, it is a state I went through. But this would be a real problem, right? Because this will be true at a moment in time, and then it will not be true. And so it just like this would create, under normal conditions, when we're dealing with pods, it will create a flaky test. And the reason why is because this will naturally hit pending and say it's true right away, and then this is going to be successful. But there's going to be plenty of times where Cuddle didn't see this, and it is now in this. It will never go back to pending, and you went through it, and we don't capture any of that. We do not capture any intermediate, or I love the term ephemeral states. We don't capture any of that. You want to put here the expectation that an end user, what does a CLI see? What does something hitting the API server see? And not only what does it see, but what will it see under the current conditions? What is the expected state that it will end in? That's what you want to put here. And that definitely throws people off. Now, if you had this thing that you wanted to capture in your controller, there might be other ways of doing it, but it completely depends on how somebody wrote it. Because what we can do is we can build out asserts against the event log. And if you had something, firing off events, we could definitely capture that, right, through the assert.
Okay, thank you.
Yeah. Now, if you like, this is index 0 and we want to get to running, this might be a perfect setup, because in maybe 0.1, we do something that causes the pod to fail, whatever that is. And then in that, we want to capture that it does go to the failed state. And so now I see, oh, it did go to the failed state. It did exactly what I wanted it to do. And then, but that's part of test design. But your mental model to capture it right, it is, what do I get from the API server under this current state? What's my end state? Yeah.
So we had the cross-plane IO guys, talk to us a while back, and this kind of goes along with what Carson was talking, where you're talking about external services. If you're not familiar with the cross-plane, it was, it's for provisioning in an agnostic way cloud resources, right? So if you have external systems that may take a bit, you're still needing some. I mean, how would you? Yeah, do you have timing issues with that? And you've got timeouts and such. How would you do that with have more of a sane state for testing?
Yeah. So a couple of things. First of all, we have timeouts on a great many things. So first of all, if I had a command, the commands tend to have, I don't know where it's at. If we had a command, we could actually put timeouts on a given command and say this command is going to take a long time. Second of all, if I had, if I put in a CRD and I just don't know, I could make this 5 minutes instead, right? And say this assert, I'm going to just wait here. Now the beauty to this is it's as you expect. If I change this test assert timeout to 5 minutes, If this turns to running, or, I wouldn't do this unless we have a CRD or we're doing a delete and I have a finalizer that's going to take forever. But the point here is, if I did it on this and I'm expecting this pod to go to running, it will return as soon as it hits running, which is awesome. So if I am adding a CRD, I set this to 5 minutes, I'm okay with it taking up to 5 minutes long, but it is ready to go within 1 minute and 20 seconds. Well, then it's going to continue going forward and the assert will be true and you're moving on to the next step.
Nice.
So we have timeouts like everywhere. And actually, in my opinion, KUTTL needs to clean up some of the timeouts, because we assume the test timeout, because that was historically the first one we had, and it got conflated into other concepts. The timeouts that need to mature look like this. Like, sometimes you want to have a timeout on a test. Sometimes you want a timeout on the test suite. Sometimes the command that's part of your setup is included in your full suite timeout, and sometimes you don't care. You only care about timeouts on the assert side. So there's a bunch of things that could probably be cleaned up a little bit in this space, but I can tell you that we do have timeouts to enable all the things you just described. I want to be able, like, this command is going to do a garbage collection on Cassandra, on a node. I'm going to use the node tool to do X, and it's going to take forever. So I want a timeout for that. That will only fail when it passes that timeout. Otherwise, it does not fail. Yeah.
Interesting.
So
Thank you.
Yeah. So for awareness, again, we built KUTTL when we built out Kudo, and with Kudo, we did a lot of work with Cassandra, with Kafka. And those were the two big ones, but there's several more that fit into that grouping. So almost anything you would want to do to test from a user perspective of those tools, we built into KUTTL. So,
nice.
And happily, I think it's exciting. KUTTL has been added to the CNCF, which clearly I haven't been to. Is it IO? I don't even know. All right, but it's added into the CNCF in the sandbox now. So if you went out to sandbox projects, you'll find it now, which is super awesome.
Yeah,
it falls under Kudo. So
that's great.
Yeah, fun times.
Well, we've kept you.
I actually expect KUTTL to go further than Kudo. So like I said earlier, I think that's, even though it falls under this, I would almost want to separate it out. But it was so much work to get here that no one has the energy.
Yeah, it seems like, it's such a tool that can be, used abroad, a lot of different operators rather than just Kudo, which is, very specific declarative type operator. But
right.
Yeah, it's cool.
Yep.
Well, any other questions? Because I know we've kept you a bit here, Ken. It's been very interesting. I've enjoyed it.
Awesome. Yeah, hopefully it helps. If you have more questions, just, again, KenSipe at Twitter or KenSipe at Gmail.
Yeah. Well, thank you very much. We appreciate it. And yeah, I'm going to have to start using KUTTL a little bit more. So anyway.